In section 3.5, we want to go ahead and prove that theorem 3-10, which is the triangle angle sum theorem. So let's take a look at the bottom of this page. Before we walk through the proof, we need to talk about something called an auxiliary line. Okay, an auxiliary line. The way that they're going to do this proof, we need an auxiliary line. An auxiliary line is simply a line that is added to the diagram to help explain relationships in the proof. Okay? Now, to draw an auxiliary line, we can't just randomly draw lines. We have to have a reason that we can draw that line. Okay? So if I just wanted to draw a line on a diagram, I might have to say that way back at when we had a postulate that said through any 2 points there exists one line. I could use that postulate to draw a line in a diagram. In this case, they're going to be using the parallel postulate at the top of your page, because they are saying that they want to draw a line through point B, and they want it to be parallel to line segment AC. Well, that's exactly what the parallel postulate says. Through any point not on the line, there is one and only one line parallel to the given line. So we know through point B, there's only one line parallel to AC. And so we're going to go ahead and call that line PR. Okay? So, looking at the proof quickly, first off, I would say that they missed a step. So I'm going to add statement 0. Because what's our given? Triangle ABC. Well, we need to state in our proof that triangle ABC is there. So we are given triangle ABC. Okay. Well, now that I know I have triangle ABC, now I can say my next statement, which is to draw line PR through point B parallel to line segment AC. That's my auxiliary line. And I know I can do that according to the parallel postulate. I know that there is one and only one line that exists with that description. Okay? Make sense what they're doing? All right. So when they did that, they now are talking about 3 angles. 1, 2, and 3. We want to prove that the measure of angle A plus the measure of angle 2 plus the measure of angle C add up to 180 degrees. And angle 2, angle A, and angle C are the 3 interior angles of our triangle. So how the heck can we prove that? Well, what they do next is they say, well, we know, or they say that they know, that angle PBC and angle 3 are supplementary. Let's take a look at those angles quick. So angle PBC is this angle here. There's angle PBC. And angle 3, they're saying, is supplementary to that. Why? What's our reason for that? How do we know? How do we know that angle PBC is supplementary to angle 3? What was that? I can't hear you. Linear pair postulate says so. Those 2 angles form a linear pair. And so this is the linear pair postulate. Okay, we've got to go back and study our postulates and theorems that we've talked about for a long time. They still show up in proofs. Okay, don't forget those. All right, so they are then saying that since we know angle PBC and angle 3 are supplementary, they want us to say something according to the definition of supplementary angles. Well, what do you suppose the definition of supplementary angles says? Add up to 180 degrees. So what do you suppose I should write for that statement number 3? Well, I can't talk about a 1 and 2 yet, because right now the statement above it talks about angle PBC. Okay, and you are 98% correct. The only thing you missed is you didn't say the measure of angle PBC. You said the measure of angle 3, but you didn't say the measure of angle PBC. So yes, we have to write the measure of angle PBC plus the measure of angle 3 equals 180. That is what the definition of supplementary angles tells us. All right, well now, the next step, they say the measure of angle PBC equals the measure of angle 1 plus the measure of angle 2. Where the heck did that come from? It's the angle addition postulate. Okay, and folks, I know you heard me say that I'm recording this, but they can only hear me on the recording, so don't be afraid to speak up a little bit louder when you're talking to me, okay? We don't need to all whisper today. All right? Okay. So, angle addition postulate. We know that the measure of angle PBC equals the measure of angle 1 plus the measure of angle 2. Now, their statement number 5, they all of a sudden say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Well, where the heck did that come from? Substitution property of equality. They are taking this statement and substituting it in for the measure of angle PBC. Substitution property of equality. Next, they say angle 1 is congruent to angle A, and angle 3 is congruent to angle C. How the heck is that possible? How is angle 1 congruent to angle A? They form the Z. Angle 1 and angle A form that Z shape. And because we know that line PR is parallel to line segment AC, we know that because we made it that way. We then know we have the alternate interior angles theorem, which, by the way, they do state right here. Okay, they give us the reason. All right, so angle 1 and angle A are alternate interior angles. They form that Z shape. Angle 3 and angle C also form that Z shape. They're alternate interior angles and therefore congruent. Cool. Their next step is the measure of angle 1 equals the measure of angle A, and the measure of angle C equals the measure of angle 3. I said that backwards, but it's still true. And that's because of the definition of congruent angles. Okay? So now, what is our, looks like, last step in the proof? What do you suppose? Writing the last step in a proof should always be easy. You should always get full credit for the last step of a proof. It's what we're trying to prove. Okay? So writing the last statement should always be easy. Now the question is, what's the reason for that statement? Absolutely, it's the substitution property. They're taking the measure of angle A and plugging it in for the measure of angle 1 in statement 5. They're taking the measure of angle C and plugging it in for the measure of angle 3 in statement 5. So again, that's the substitution property of equality. Okay, so there's multiple ways of proving the triangle angle sum theorem, but that's one way of doing it. Okay, questions on that proof? On the back side of your notes, I quickly want to talk about our vocab from yesterday. Because we just quickly talked about the theorem, okay? But I want to make sure everybody understands where that theorem comes from as far as the vocab involved. So first off, the exterior angle of a polygon, and this is true for any polygon, not just triangles, is an angle formed by a side and an extension of an adjacent side. So all they're saying is, if I take a side of a polygon and extend it out, and then the side next to it there, it's forming an exterior angle. Angle 1 there is an exterior angle. It's outside the triangle. That's why it's called exterior. Okay? Something else that I want you to know that they're not saying here, but an exterior angle is always a linear pair with the adjacent interior angle. Always, always, always. An exterior angle is always a linear pair with the adjacent interior angle. Okay? Then the next vocab is the remote interior angles. So, for each exterior angle of a triangle, this isn't true for all polygons, for each exterior angle of a triangle, the two non-adjacent interior angles are its remote interior angles. Okay? So the remote interior angles are the non-adjacent interior angles. The two interior angles that are not right next to it. Okay? And that then brings us to what we talked about briefly yesterday, which was that triangle exterior angles theorem, that the measure of each exterior angle of a triangle is equal to the sum of the measures of its two remote interior angles. Questions on the vocab on that? No? Then let's take a look at a couple of examples. Here they are. Looking at example number 1. How am I going to solve for the measure of angle 1? 80 and... Okay, I see that angle 1 is an exterior angle. Okay? First off, I can identify that because I see that it forms a linear pair. I see it forms a linear pair with its adjacent interior angle. Right? So, it's an exterior angle. That means the measure of angle 1 is going to equal 80 plus 18. Measure of angle 1 is going to equal 80 plus 18. So the measure of angle 1 equals 98 degrees. Is that the only way to find angle 1? Absolutely not. We could use the triangle angle sum theorem and say, well, I know that these three interior angles of this triangle must add up to 180 degrees. I could find this angle first by taking, that angle plus 80 plus 18 equals 180. And subtracting that out, I think I get, 82? Right? So I'd get 82 degrees. And then once I knew that that was 82 degrees, then I could use my linear pair postulate and say that the measure of angle 1 plus 82 must add up to 180. And guess what? I get the same answer. I get 98 degrees. Okay? But that way's a little longer. That's why having that exterior angles theorem is nice. It's handy. Okay? Questions on finding angle 1? Both ways? Well, then what about example B? How are you going to find the measure of angle 2? Somebody else. Again, there's two ways to find the measure of angle 2. Can anybody explain one of them to me?
Could you take 124 minus 180 minus 124 to find that inside?
Okay, so you're saying you want to try to find, say, angle 1 first. Okay? And so then you'd say the measure of angle 1 plus 124 equals 180. And so subtracting 124, the measure of angle 1 equals 56.
And then add those two together.
Okay, and then you're going to say what?
Add 56 and 59.
I always want you guys to set up the equation first. Don't just automatically start adding stuff and subtracting stuff. What is the equation we're solving? Do you know?
The measure of angle 2 plus 59 plus 56 equals 180.
There we go. And then we can add those two together and subtract it from 180 and get the measure of angle 2. Excellent. Yep, that would work. But there is another way.
Could you do 124 minus 59 equals the measure of angle 2?
Equals, I always want you to write the equation first. That exterior angle is going to equal what?
Measure angle 2, right? Yeah. Minus plus 59.
The exterior angle is equal to the sum of its two remote interior angles. And so this angle will equal this angle plus that angle. Again, have that visual of the paper we used yesterday. Right? When we lined up those three angles in a triangle, they all lined up on a line. And this angle out here is essentially formed by those two other angles because we already have this interior angle of the triangle here. So this would be 56, this would be 59, this would be angle 2. When we did that, right? And so, subtracting 59 from both sides, what do we get for the measure of angle 2? 65? Cool.